Hi, welcome back. On today's lecture series, we are going to discuss about the types of unsymmetrical faults. So here we have to know what is symmetrical fault and what is unsymmetrical fault. So actually the fault involving unequal current in three phases or an unequal voltage drop across phases is called unsymmetrical fault. Suppose if it is a symmetrical fault, all the three phases are getting faulted, that is called three phase fault. But unsymmetrical means it may be an single line to ground fault, line to line fault, or double line to ground fault, etc. So why it is important? Because around 70 to 80% of all faults will be accounted here, and it will be more complex analysis can be required, and for the production it will be more critical. So in the empathy stage, so there are several questions are there. So what is symmetrical component and how the symmetrical component can be used to determine the unsymmetrical values, and what is the sequence network, how to analyze, and what are the different types of fault conditions, and how it will be physically occurred, and how we have to connect with the real-time applications, and how we have to analyze the fault analysis, how we have to protect the equipments, so etc. So from the empathy, we have to define what we are going to do. Here, here we have to analyze and solve the unsymmetrical fault using symmetrical component method. So first of all, we have to classify what are the different types of fault and what is its characteristics. And here there we have to apply the symmetrical component effectively, and from that we can able to calculate the fault current and voltages. So in the ideal stage, so these are the different types of unsymmetrical fault. One is a single line to ground fault, another one is line to line fault, and next one double line to ground fault. So the most common fault is nothing but single line to ground fault. So around 70 to 80% of fault which are occurred as single line to ground fault. So here any one phases it is touches with the ground. So that is called single line to ground fault. That may be either R phase or Y phase or B phase. If we go for line to line fault, it is the frequency, it can be around, with the possibility of fault, it may be around 15 to 20% of fault. So here the two phases are short together. So at the time of any large amount of wind speed, or some of the trees or coconut wall, something, it may be fall on the line and two lines are getting touching each other. So it is called line to line fault. So the possibility to occur is 15 to 20%. And the double line to ground fault, so it is very rare, and it is less in common, around 5 to 10% of fault, and the two phases are connected with ground. So here the single line to ground fault, it is a physical condition. It may be an R phase or Y phase or B phase. It contact with the ground. Okay. So the sequence network connection, all three sequence, the positive, negative, zero sequence, which are connected in series. And the fault current, the fault current is equal to 3 times of IA0, or it may be 3IA divided by zero sequence impedance plus positive sequence impedance plus negative sequence impedance. And for line to line fault analysis, the characteristics, it may be any two phase short together. Now we can assemble here, we can take B phase and C phase short together, and there is no ground which is involved, and the zero sequence current is 0. So therefore IB plus IC is equal to 0, or it may be IB is equal to minus IC. So here the positive and negative sequence are connected in parallel connection. So this is the formula to determine the fault current, which is equal to √3 times of IA1. And the double line to ground fault. So here the fault description, any two phases, like we can take a phase and B phase short to ground simultaneously. It is most severe unsymmetrical fault, but is less than common. And the sequence connection, positive sequence in series with a parallel combination of negative and zero sequence. And the current calculation IA1 is equal to IA divided by zero sequence plus positive sequence positive sequence divided by zero sequence. So this is a comparison of fault severity, and this is an three phase fault, the more severity, the more dangerous is three-phase fault, and after that double line to ground fault, another one is single line to ground fault, and the next priority is line to line fault. This is the severity of fault. And this is a real-time application. It can be used for the production system like a distance relay, overcurrent relay, or it may be calibrated for certain specific types of relays. And fault location system. Here we have to identify what is the exact fault location on the transmission line for quick restoration. And smart grid management. So automated fault detection, isolation, and service restoration, everything can be managed here. And for the equipment rating, the circuit breaker and switchgear selection is based on the fault current levels. And in the mind map, the single line to ground fault is most common, around 70 to 80%, and double line to ground fault, double line fault is around 15 to 20, and double line to ground fault is less in common, around 5 to 10%. Okay, these are the unsymmetrical faults. So this is an accurate challenge. Why is a single line to ground fault more common than other types, despite seeming less likely to occur? So if you know the answer, just put it in the comment section. And this is an assessment for the same system. Which fault gives high current, either line to line or single line to ground fault? So justify mathematically. So for here also, just you can see the calculations. If you have any queries, just post in the comment sections. And these are the few textbooks and reference books on online resources for this topic. Thank you.